Now let's solve an exact equation, and in particular, let's solve 2 cosine y plus 2y squared plus minus x sine y plus 2xy times y prime equals 0. And here the hint is multiply by x first. We'll need it in a sec. Now, when to use exact equations? First of all, if everything else fails, because you can't put it in y prime plus py equals f of t, you can't really separate the variables. So you think, okay, maybe I can use exact equations. And also here the hint says multiply by x first. That's another thing. Because it turns out, you can try it out, the equation itself is not exact, but if you multiply it by x, it becomes exact. So let's do that. X times 2 cosine y plus 2y squared plus x, and then minus x sine of y plus 2xy times dy over dx equals 0. And then we want to put it in the form p dx plus q dy. So let's multiply this by dx, and we end up getting 2x cosine y plus 2x y squared dx plus minus x squared sine of y plus 2x squared y dy equals it. So this is our p, and this is our q. Again, always p dx plus q dy equals 0. All right, and now let's check if it's exact. Check exact. Again, that's where yours truly comes in. So let's check that Peyam is quixotic. So py, that is 2x cosine y plus 2x y squared with respect to y. So that's minus 2x sine of y, and then plus 4xy. And now let's do qx. Qx, so that becomes minus x squared sine of y plus 2x squared y with respect to x. And that becomes, so minus 2x sine of y plus 4xy. And it's a match, and they lived happily ever after. And now the next step is to find our potential function. Find f of xy. So now what is going on? So what we have, fx equals p. So f of xy is the integral of p with respect to x. Now careful, don't use py. Don't use minus 2x sine of y plus 4xy. Use the original thing. So 2x cosine y plus 2x y squared with respect to x. So that just becomes x squared cosine y plus x squared. And x squared y squared plus g of y, constant with respect to x, so any function of y. And then same thing, so fy is q. So f of xy is now the integral of q, which was minus x squared sine of y plus 2x squared y dy. Now remember, an antiderivative of sine of y is minus cosine. So minus x squared minus cosine of y, and then plus 2x squared 1/2 y squared plus constant with respect to y. So any function of x, and we get x squared cosine y plus x squared y squared plus h of x. So what is our function? F of xy is x squared cosine y plus x squared y squared. And then what is our solution? So the equation kind of tells us the derivative of f is 0, so f is a constant. So step 4. Solution. So x squared cosine y plus x squared y squared equals to a constant. And here we can't really solve for y in terms of x. So this is really the best we can do. Oh, perfect. There we go with the box. So once again, do exact equations if actually you can put in the form p dx plus q dy equals 0, where Peyam is quixotic, or kind of if everything else fails.